Okay, and I will share my screen. So I will share my screen. Okay, so everybody can see my screen, you can hear my voice.
Can, Doctor.
Okay, thank you for the response. So maybe from time to time I will ask you to respond to me because I hope that I'm not talking alone. Okay, there's in the previous last semester. Okay, there's a time when the connection suddenly drop. The internet suddenly down at my side, and at that time is during the lecture session. So I didn't realize for about 20 minutes. Okay, I've been talking alone for myself, and then the students send me message. Okay, I have been disconnected at that time. So what happened is that I need to repeat again for the past 20 minutes that I've been talking alone. So because now I'm sharing my screen, so I cannot see you. Okay, unless I open the Google Meet like this, so I can see you like this. Okay, so so I will begin. Maybe we can start discuss about the author system. Okay, so I have put all of you in the author system. Okay, for BEJ 30103. So both sections share the same classes. Okay, share the same class for this subject ECS. Okay, so I've put both section under the same class, and if you see from here the course info, I have put the course info here. Okay, and I've put the WhatsApp link. So if you see that your friends are not in the group yet, so please invite them using this using this WhatsApp group link. Okay, boleh invite kawan-kawan yang masih belum ada dalam WhatsApp group. Okay, and then recorded lecture video I will put in the YouTube. So I have created a playlist for section 1 and section 2. Okay, and if you see it here, for example here I have created both section 1 and also section 2 playlist, so you can see later the video after the class. Okay, I will upload here. Okay, saya akan masukkan ke dalam sini. Okay, and there's dates, important dates. The first one is test, so we're gonna have one test and one quiz. Okay, so the test I suggest to be conducted on 13th of May, on Thursday, 10 to 11 in the author system. Okay, and then the quiz, so test would be subjective. Okay, subjective open book. We're gonna do online. Okay, kita akan buat online. This maybe consists of 3 subjective questions. The time, the duration gonna be 1 hour 30 minutes. So will be conducted through the author. So you will download the question, you answer the questions, and then you upload the answers in the author. Okay, and then on the 16th of June I plan to do the quiz, objective quiz through the author. Okay, so regarding the topics I will explain more details later, but normally for test, okay, for test it is up to chapter number 3 about the amplitude modulation. Okay, amplitude modulation under the topic of power calculation for the AM amplitude modulation. Okay, this one I will explain later about the specific topics. Okay, no problem. And quiz on the 16th of June, normally quiz for chapter 4 and maybe some of chapter 3 at the end of chapter 3 plus chapter 4. Okay, for quiz. So this is objective questions. Okay, and I have put the lesson plan here, RPP. RPP is a lesson plan, rancangan pengajaran dan pembelajaran. Okay, so this is the lesson plan. So I will explain about the lesson plan after this. Okay, so we can browse through the author system. Okay, if you see from here, I have put all the lecture notes. Okay, so we're gonna have 5 chapters, chapter 1 until chapter 5. Okay, I already put all the notes in here. Okay, PDF notes, so you can download and learn by yourself for the notes. So the notes are the lecture notes that I will explain during the class session. Okay, and then we're gonna have a problem-based learning project. Okay, so the PBL project. So the PBL project gonna consist of 2 tasks, first task and second task. I will put the instructions later. Maybe next week I will put the instruction over here. Okay, the first task and also the second task. So this is a group project. Okay, and then I already put the books. Okay, the books. So the books you can see from this link bit.ly ECS books. Okay, this one. And if you open this, I already put 3 books. Okay, communication system, electronic communication system, fundamental through advanced, and also Frenzel principle of electronic communication system. So for you, most of the time we're gonna use these books. This book, electronic communication system, fundamental through advanced. So this book is written by Wayne Tomasi. This is the first edition. Okay, the second book is that you can refer is this one, Frenzel, Frenzel Principle of Electronic Communication, 4th edition. Okay, so this is the first edition and this is the 4th edition. So both books are good. Okay, but your lecture notes is based on Wayne Tomasi's book, this one. Okay, so I only have the first edition. If you want to get the 5th edition, the last edition is the 5th edition. You can get from the library. Okay, or you want to buy for your own. Okay, it's also good. Okay, so here I have the 5th edition. Saya ada 5th edition di sini. I have the 5th edition, this one. So this is the 5th edition of Wayne Tomasi's book. Okay, so it's very thick. Okay, so this is fundamental and also for advanced level. Okay, so if you, in my opinion, if you want to buy this book in the bookshop, it's also good for you. Okay, because you can use it until you die. Okay, forever. Okay, even for me, I'm still reading this book. Okay, saya sendiri masih membaca buku ini. Okay, I'm still reading this book. And then this is for the book, and if you see, I also put the past year questions. Okay, I also put the past year questions, tutorial, test 2, final exam. So you might wonder why there's a 2 tests. Okay, a long time ago we have 2 tests, but now we have only 1 test, because most of the marks are distributed to the group project. So that means easy for you to score this subject. Okay, because the project gonna be 20%. Okay, and if you open this one, okay, based on the previous experience, student complained that this link cannot be opened. Okay, and we realized that maybe sometimes you will be unable to open the link if you are using the Google student ID. Okay, maybe. Okay, I'm not sure about that. But if you are using your own personal Google account, for example, or other account, you might you can open the links, the given links. Okay, I don't know why. Okay, I don't know why. For example, I opened the final exam question. This one. So I have put all the previous semester's final exam questions. Questions only. Okay. So I've put in the Google folder. Okay. So if you are unable to open the link I suggest you to try to use your own Google account and try to open the link, okay, if you have problem. Okay, so these are all the questions. These are the question banks. Okay, there's no answers bank yet. Okay, so my suggestion, because this is too many questions, so I believe if you are alone, you cannot do all of this. There's no time. So my suggestion is to collaborate with your friends. Okay, for example, you do question number 1, and then you share your answer in the WhatsApp group. Then another friend do question number 2 or number 3, and so on. They will share in the WhatsApp group. So together you can make the answers bank. That's my suggestion. Okay, because you cannot do all of this in one semester. Too much. Okay, terlalu banyak. So saya cadangkan kamu collaborate dengan kawan-kawan. Okay, seorang buat suatu soalan, another soalan lain, and then you share in the WhatsApp group. Okay, and you can also ask me whether your answer is correct or not. Okay, so when you want to ask me, I suggest you to do the question first, then you can ask me. Okay, do the question first, and then you can ask me whether your answer is correct or not. Okay, I will give my comments on your answers. I will give the comments to your answers. Okay, no problem. Okay, so these are the final exam questions, and there's more tests and also the tutorial. Okay, I think for the last semester I will put later. Maybe I forgot to put the last semester, the previous semester. Okay, semester 1, I will put later here in the folder. Okay, so you can browse through the links. Okay, and then the student list, we have section 1 and section 2, total around 65 students. So section 1 around 36, and section 2 is 29 students. Okay, and there's no individual activity yet, but I already put a group activity. Okay, your first task is to form a group. Find your group member. So you go here for section 2. Okay, so you can see that I already created for 6 group. Maximum is 5 students. Okay, so since we have 29, so most group will be 5 students and one group will be 4 students. Okay, so please make sure you find your group members as soon as possible, and I hope that you can finish this task by this week, and next week we can begin with the project instruction. Okay, so now your job is to find a group member. Okay, and please make sure when you already put your name inside the group, you need to contact your group members. Please make sure you contact your group members. Okay, pastikan kamu contact group member, because there's a case in the previous semester that a new student put his name in the group. Okay, and the other group members don't know about the existence of this student. Okay, group member yang lain tak tahu kewujudan pelajar ini. Sehinggalah, okay, until in the middle of semester, almost the end of semester, then suddenly they realize that there's one more group member. Okay, so there's a issue that they don't want to share the marks with the students. Okay, so that's the issue at that time. So I hope that when you have formed the group, please contact all of them. Make sure that you have their contact numbers, and you need to give all your commitments. Okay, and remember, okay, so we're gonna I hope that does not happen in this semester. If let's say there's a student one or more students in the group that are not willing to collaborate to do the project. So they don't want, for example, this student don't want to meet in the to have a meeting, group meeting, don't want to do the given task and so on. So please inform me earlier. Okay, so if there's a problematic student, you need to inform me earlier. Okay, so what happened next is that, okay, you have the options. Okay, so I told you now, if let's say there's a group member, okay, there's a group member in your group that are not given the commitment to the project, then you can kick this group member out from the group through the meeting. So what you need to do is you need to inform me there's a problematic student, we want to kick out this student. So what you need to do a group meeting, record the minutes meeting, and then you can inform me. So I will ask this student to do the project by his or herself. Dengar So maknanya kalau ada pelajar yang tidak memberikan komitmen, biasanya satu orang lah, satu orang ni kadang-kadang dia bermasalah dalam grup So what you can do a group meeting, discuss, and then you can vote that okay, we don't want this group member. Okay, we don't want this group member, for example. Okay, so do a meeting, make a minutes meeting, record it. Okay, dicatat you record in a minutes meeting, and then you can inform me. Okay, we agree. Okay, all of us agree that we want to kick out this group member. Okay, so what happened is next, I will agree with your decision. I will ask that person to do the project by his or herself. So berhati-hati so be careful about this. So if you want to be in a group, make sure you do your commitment. Give your full commitment. Okay, don't burden your group members. Okay, please don't burden your group members. You need to give the best to your groups. Okay. And then assessment later, I will put some of the tests and quiz. Marks also will be given here later. Okay. So do you have question about author system? Kalau ada soalan boleh tanya regarding the author. Okay. Do you have question about author? If no question, anybody still have problem with the author? If not, I can explain about the lesson plan. Okay. So lesson plan you can get from here, from the course info. If you go down here, there's a lesson plan, RPP document. Okay. So if you open the RPP document, this one. Okay. Electronic communication systems. So this is a lesson plan for one semester. Okay. So the code, make sure you are in the correct codes. Saya harap saya tidak salah. So code ini betul BEJ 30103. So this is a core subject. Okay, this is a core subject in the BEJ program. So this course introduces the fundamentals in analog and digital communication system. That means these are the keywords, analog and digital. So you will learn both of it, analog and digital. Even your project consists of analog and digital. Okay, so comprises of analysis of signals and noise, generation of analog and digital modulation schemes, transmission lines and wave propagation as part of communication systems. Finally, the topic discussed relate with the current application in the communication systems. Okay, so actually there will be two lecturers. Okay, actually there are going to be two lecturers, me and also Mr. Ezri. Okay, so Ezri now is in a long holiday because his wife is in critical conditions, very sick. So he will come back on the second half of the semester. So Mr. Ezri is supposed to teach section 1. I'm supposed to teach section 2. Okay, but for now I will take over both sections, section 1 and section 2. Okay, for now. Okay, so this is a 3 credit subject, and this is the course learning outcome. So course learning outcome is what we expect you to be able to do at the end of the course. This is our expectation. Okay, so you, at the end of the course, you will be able to analyze various types of analog and digital modulation techniques and suitable methods for electronic transmission. And then you will be able to practice professionalism in work related to the electronic communication systems. You will be able to construct a report and do presentation in work related to electronic communication system. Okay, so these are the numbers. LOD. LOD is the learning outcome domain. PLO is the program learning outcome. Okay, but I want to explain about this taxonomy level. Okay, so if you want to know, whether a subject is difficult or not, macam mana nak tahu satu subjek itu susah atau senang? Normally you ask your seniors. Normally you ask your seniors, this ECS subject is difficult or not? Maybe some of them will say difficult, some of them will say not difficult, easy, something like that. Okay, but what is the black and white documents that specifically mention about the level of each subject? Okay, so in order to know the level of subject, you need to see the you can see the syllabus document, or you can see the lesson plan document. Okay, you need to see the taxonomy level, this one. Okay, so I told you, so that means taxonomy level normally consists of 3 domains: cognitive domain, C domain, affective domain, and another one is psychomotor domain, P domain. Okay, so for affective domain and another one is psychomotor domain. So here this subject don't have the psychomotor domain. Okay, so for affective and psychomotor domain, normally we assess through the assignment or project, normally. Okay, and this one, cognitive domain. Okay, these are the domain, the knowledge domains that we assess you through test, quiz, and also the final exam. And normally this cognitive domain determines the level of difficulty level of each subject. The highest would be level 6. Okay, yang tertinggi adalah level 6. So this subject is level 4. Okay, so we have a low level, level 1 and 2, intermediate level 3 and 4, and high level is 5 and 6. Okay, so level 4, what is it? Level 4 is up to the analysis. Okay, level 4 is up to analysis. Okay, so you analyze the given, you are given the questions up to the level of analysis. So if you ask me, is this subject difficult or not? So this is the intermediate level subject. It is not too easy, it is not difficult. Okay, all of you have the same opportunity to score A or A+, no problem. Okay, so ini these are the evidence. So kalau kawan kamu tanya, inilah dia bukti ni. These are the evidence that this subject is not the high level, is a intermediate level. Okay, and then what? So how do we assess each learning outcome? So we assess for CLO1, course learning outcome 1, we will assess you through test, quiz, project, report, and final exam. And then for learning outcome 2, we will assess you through the project. So we're going to have project report and video presentation. Okay, similar for learning outcome 3. Okay, and then the KPI. So KPI is actually the KPI for the lecturer. So that means my target, the minimum target is that 50% of the student achieve 55% of marks. That means my target, at least I want to make, I should produce, okay, I should produce the minimum 50% among all of you achieve C plus and above. That's my target. Okay, minimum target. Kalau saya, if I can achieve that, that means my KPI is achieved. Okay, for each of the learning outcome. And I hope all of you achieve a 50% C plus and above. Okay, I hope all of you achieve A or A plus. That's my target. Okay, it is not, it is possible. You just need to study. Okay, study. Don't study last minute. Okay, don't study last minute. And then if you scroll down, so this is transferable skills. Transferable skill is the skills that can be that can be transferred after you have completed the course. Okay, for example, ethics, professionalism. So you're gonna increase your skills in the ethics and professionalisms. You're gonna have more good communication skills and also the numeracy skills. Okay, and then distribution of student learning time. So how do we distribute the course content throughout the semesters? Okay, so there's total is 14 weeks. Left side here is a week. This one is the topic chapter. Okay, this is the topics. Chapter 1, for example. So now we do the online 3 hours. Okay, so what is this? 3 hours non-independent learning. That means I expect you to study on your own regarding today's lecture topic. So this is the number of hours that I expect you to study on your own in order to have a fully understand of what I'm explained today. So total is 6 hours. Okay, so chapter 1 will be teach for 2 weeks. Okay, 2 minggu digunakan untuk mengajar chapter 1. Okay, chapter 1 is introduction to communication system. You will be learn about the basic concept of communication system, and also you will learn about the power measurements, gain and attenuation. Okay, so this 1.5 is gonna be asked in tests and also in the final exam. Okay, there's a lot of questions about this 1.5. Okay, this is a calculation topics. The others are the theoretical concept topics. Okay, in chapter 1 only this related to the calculation topics. And then the noise. Okay, what is the type of noise, how to calculate the noise power, how to calculate the signal to noise ratio, noise temperature, and then noise factor, noise figure. So that one you're gonna need to learn in chapter 2. Also we learn chapter 2 through online until week 4. Starting from week 5 you will learn about analog modulation. Analog modulation. So chapter 3 analog modulation, you will learn all about analog system. Okay, so chapter 3 is the biggest chapter in this subject. It consists of 2 parts. The first part is amplitude modulation, AM. You will learn about basic of AM, power calculations, AM circuit for transmitter and receiver. And then we move to part 2 of chapter 3, which is the angle modulation. Angle modulation consists of frequency modulation, phase modulation. You also will learn about power calculation and also the circuit design for the transmitter and receiver. Okay, and then what? You will learn about the circuitry of the analog receiver circuits. Okay, so this also among the favorite question that will be asked in the test and also final exam. Especially final exam, we like to ask this question, analog receiver. Okay, banyak soalan ya. There's too many things that can be asked for these topics. Okay, and then until week 8, you will learn chapter 3 until week 8. Okay, the last week is advantage and disadvantage. Okay, and then week number 9, we start with digital modulation and transmission. This is chapter 4. So chapter 4 is about digital system, where you will learn about the formatting process, encoding process, decoding process, modulation techniques, the block diagram of the transmitter and the receiver, and many others. Okay, and also the digital modulation techniques, which include the ASK, amplitude shifting, frequency shifting, and also phase shifting, and finally the quadrature amplitude modulation. So these 4, 1, 2, 3, and 4, these are the digital modulation techniques. Okay, these are the digital modulation techniques. Okay, and you see that until week number 10, we're gonna learn online. Okay, until week 10, and my plan is to do face-to-face. Starting here is face-to-face. My plan is to do face-to-face class starting at week 11. Okay, so siapa yang belum ada rumah, if you don't have the still don't have the place to stay, you still have time to find a place. Okay, masih ada masa untuk cari tempat tinggal. Okay, so my suggestion, try your best to find the place to stay. Okay, you have 10 weeks to find. More than 10 weeks, because you're gonna have a public holiday, especially during the Idul Fitri holiday. Okay, so my plan is to do face-to-face class starting from week 11, 12, 13, and 14. So I hope that you will be able to stay around Parit Raja. Okay, please try your best. Okay, we still have time. Okay, try your best. Masih ada masa. Ni kalau nak tanya boleh tanya. If you have question, please ask me. Please ask question, no problem. Okay. And then the last chapter is chapter 5, transmission line, antenna, and propagation. That's chapter 5. Okay, and for your information, okay, before that, chapter 4 is actually a part of another subject. Okay, for BEJ program, we have digital communication subject, where you will learn that subject later in year 4. Okay, so chapter 4 is only a small portion of digital communication subject. Okay, and then when we move to chapter 5, if you see from here, we're going to have 3 big topics. Okay, 3 main topics. The first one is the transmission line, okay, antenna, and propagation. Propagation here is the wave propagation. So chapter 5 is actually consists of is actually a portions of 3 different subjects in BEJ program. Okay, dia sebenarnya terdiri daripada dia adalah sebahagian daripada 3 different subjects. Okay, for example, Transmission line, you will learn this. There's a lot of this topic in the electromagnetic compatibility subject. Okay, electromagnetic compatibility subject. And then we also have an antenna subject, elective subject. Okay, and we also have about wave propagation, which is the wireless and mobile communication subject. So if you ask me, this is like a three-in-one subject. Okay, 3 subject in 1 chapter, something like that. Okay, but just a very general concept about these 3 main topics. Okay, so transmission line, antenna, and propagation. So you see that first 12 on the week 12, you're gonna learn about transmission line, and starting about radio and antenna, and then week 13 about antenna, and the last one will be transmission about wave propagation. Okay, the last week would be wave propagation. And for your information, wave propagation is the favorite topic and has been asked in the final exam in every semester. Kita biasanya suka tanya soalan topik ini. We like to ask these topics in the final exam. And if you see from the question banks, the question quite similar from each semester, almost like a similar question. Okay, hampir sama dia punya bentuk pattern. The pattern is quite similar. Okay, so total 89 hours for 1 semester, and this is the assessment. So please see, see this lesson plan. You see that here we're gonna have 3 kind of assessment. Okay, continuous assessment. The first one is test. Test is 20%, so expected on week 7. Okay, week 7 is excluding mid-sem break. Excluding mid-sem break, because the test gonna be after the Idul Fitri holiday, or after the mid-sem break. Okay, and then quiz. Okay, so you see that quiz we expect for 2 hours. Okay, one and a half or 2 hours. Okay, and I expect you to learn at least 4 hours for the test. Okay, quiz normally this quiz is objective questions, 10% of total marks. We're gonna expect on week 12. So around 1 hour of quiz, and maybe you need at least 2 hours to learn about the quiz. Okay, and then project, we're gonna have project assessment is divided into we have 2 tasks, task 1 and task 2. Each task you need to produce report and recorded video presentation. Okay, setiap task ada 2 task. Setiap task you need to do report, project report, a group report, and also group presentation, recorded video. Okay, so the marks gonna be for first task 10%, second task also 10%, so total gonna be 20%. And how do we divide the marks for presentation and report? So presentation around 12%, report around 8%. So this project is for will be done in week 2 until week 14. Okay, so these are the because we're gonna have 2 videos. One video is half an hour, another video half an hour, so I expect here is 1 hour. And then report, we're gonna have 2 reports, so I put 1 hour for each report. Apa maksud 1 hour for each report? So I expect to write the report, okay, collaboratively in a group. It will take around 1 hour, excluding the preparation time. So preparation at least 6 hours estimation. Okay, kalau just writing the report, it is not too much. Okay, if you write collaboratively among group members. Okay, and then what? Final exam, the last one. Final exam 50%. Okay, final exam 50%, and expected on week 16. Okay, for 3 hours. So final exam, we're gonna have 5 questions for the final exam. Each question for each chapter. 1 question for each chapter. Okay, 1 question for each chapter. So we have 5 chapters, so we're gonna have 5 questions, subjectives. Each question 20 marks. So total 100% will be rounded up to 50% of your carry marks. Okay. So the grand total student learning time is 120 hours. Okay, so these are the calculations here. So and then special requirement, you might need a MATLAB software for your task number 2. Remember, you need a MATLAB software for task number 2. So you can download the MATLAB from the website in the MathWorks website. You can download using a university's license, because UTHM has subscribed to MathWorks. So actually you can download the MATLAB and install the MATLAB in your computer using your student email. Okay, using your student email. Because UTHM already subscribed to MathWorks, so you are eligible to download and to use the MATLAB using a university-wide license. So this one you can ask the PTM or the IT center how to do it. But if you ask me, I can also guide you how to download that one. Okay, you just need to go to the MathWorks. Okay, so you go to the MathWorks. Okay, MathWorks, this one, I think some of you already download that one. Okay, so first of all, you need to you can get the MATLAB. Okay, get MATLAB. Okay, so you can try campus software. Okay, for your school. So check for access. So make sure you use your student email account. Student email account. But first you need to register. Okay, you need to register using your student email, and then they will do some verification, and then you can download for free. Okay, no need to pay. Okay, so that one is for the MATLAB. MATLAB will be used for the second task. Okay, first task no need to use MATLAB, you just need to do the calculations. Okay, reference book. Okay, this is the reference book, Wayne Thomas's, the book that I showed you previously, 5th edition. Okay, and then what? And then the course attendance. Remember this one. This is standard. Okay, this is the standard university regulation. Student must attend not less than 80% of the contact hours. This is not said by me. This is the university regulation. What does this mean? That means you cannot absent without any evidence, without any reasons for 20%. Okay, tidak boleh tidak hadir, tidak boleh ponting sebanyak 20% tanpa sebab yang munasabah. Okay, so my advice, you see that 20% of absence, that one is considered as 3 times of classes. Okay, 3 times of lecture. So 3 hours, 3 hours, 3 hours, so 9 hours. So 20% of absence is equivalent to 9 hours of lecture session. That means 3 times, 3 weeks. You cannot absent for 3 weeks without reasons. Okay, so if you want to absent, make sure you have student, make sure you have a doctor certificates, doctor MC for the medical certificates from the doctor. That's the first. Second, if you are involved with the university program, you can ask for the official letter, no problem. Okay, and for example, you don't have any evidence. For example, okay, for example, like you fell asleep during the class time, during the class session. For example, you are sleeping from 1:30 p.m. for example. Okay, you fall asleep and then you wake up 5 p.m. So that means you already missed the class. Okay, so what you can do is, if that happen, okay, so pernah ada terjadi juga ya. So if that happen, what you can do is you need to write your own letter, write an official letter to me. You sign, and your PAK, your penasihat academic, also need to sign the letter. Okay, your PAK, your PAK needs to know that you are sleeping during the class session. So if your PAK sign the letter, I will accept the letter. If you are only sign on your own, I will not accept the letter. Okay, I will only trust you if your PAK sign the letter. That's it. Okay, so pernah terjadi sebelum ini. Okay, so what the students do, what the students did, they write the official letter to me. That student signed the letter. The PAK also signed the letter. Okay, so that one is the evidence of absence. Okay, so attendance will be taken at the end of the class. Okay, I will take the attendance at between 4:45 until 5 p.m. So actually, if you want to go somewhere now, it's no problem. Okay, attendance will be taken between 4:45 until 5 p.m. So make sure you are here at that time. Okay. So that's all for the lesson plan. Okay, itu sahaja untuk lesson plan. So do you have any question to ask regarding lesson plan or regarding the face-to-face classes or not? If you don't have questions, I will proceed to the next part of today's lecture. Okay, so this is my plan starting from week 11. So try your best, try your best. We still have time. Okay, what about final exam? Should we do face-to-face or should we do face-to-face or online? Okay, so there's I don't have the answer for that for the final exam. For now, we assume that the final exam will be conducted as online for now, because we are still not receiving any information from the academic management office whether the final exam is face-to-face or online. Okay, so we assume for now is online. Okay, similar with tests and quiz, we will conduct the test and quiz online. Because if I want to do face-to-face, that means I need to book a hall for 65 students. A hall needs to be booked through the academic management office, and they don't come up with the new regulation yet about the face-to-face exams. Okay, so what we can do is we need to do online for now. Okay, so if I want to do face-to-face, I will inform you earlier, okay, weeks earlier, so that you can prepare your do the preparation to come here. Okay, kalau saya nak buat face-to-face, saya akan maklumkan jauh lebih awal supaya kamu boleh bersedia. Okay, so any questions? Ada soalan nak tanya? Any question to ask? Do you have question to ask? Feel free to ask question. Okay, remember you can ask me question anytime. You can always interrupt my lecture, no problem. Okay. Before we move to chapter 1, because today I want to start with chapter 1. Okay, saya nak mulakan chapter 1 today. But before that, maybe I can explain to you about the chapters that you will learn in this subject. So you will learn 5 chapters. So what are these chapters? Okay. So I already explained to your colleagues in section 1 on Sunday. So I will explain now to you about all the 5 chapters. So maybe you might wonder what you will learn in ECS. Okay, actually what you will learn in ECS. Okay, so maybe we can open a whiteboard so that I can explain to you. So I will open a Jamboard and I will share with all of you. So okay, so you will get the link to the whiteboard through your email. Okay, it is sent to your email. Okay, this one. Okay, so I expect you already get the link for this one. Okay. Okay, so this Jamboard is already shared to your email. You can find it later. Okay, so I will explain to you what you will learn in ECS. What you will learn in ECS. What are those 5 chapters? Apa dia 5 chapters tu? So ada banyak yang you akan belajar sebenarnya. So okay, so what you will learn, okay, is the fundamental concept of electronic communication system. So what is the electronic communication system? Electronic communication system consists of transmitter, okay, a transmitter, okay, and then a medium, or what we call as a channel, okay, and then the receiver. Okay, a communication system consists of transmitter, channel or medium, and also the receiver. Okay. Before I proceed, can someone respond? Can you see my screen? Can you hear my voice? Boleh siapa-siapa tolong respond?
Yes, Dr.
Yes, Dr. Dela.
Okay, thank you for the response. Okay. Okay, so a communication system, electronic communication system consists of 3 main components. Okay, at least 3 main components. Sekurang-kurangnya ada 3 main components. The first one is a transmitter. Okay, TX here is a transmitter. And then we're going to have the channel or the medium. Medium can be wireless or wired. Okay, so if it is a wired medium, that means both of these transmitter and receiver will be connected through a wire. Okay, either copper wire or fiber optics or any types of cable that connect a transmitter and the receiver. Okay, so we have transmitter, channel or medium, and also the receiver. So in chapter 1, okay, in chapter 1 you will learn the basic principle of transmitter, the principle of medium, and also the receiver. So it is in general about the task of transmitter, the task of medium, and also the task of receiver. Okay, so in chapter 1 you will learn in general about all of these 3 components. Transmitter, what is the function of transmitter, what is the function of receiver, what is the channel, what is the medium. So you will understand about that in chapter 1. Okay. Okay, the basic concept of these three components. Apakah peranan setiap komponen ini? Okay, what is the purpose of these components? And then what? Then you will learn about chapter 2, about noise. Noise, you know, noise is the electrical energy within the system or within the medium that disturbs the transmitted signal. Okay, it is the electrical energy that degrades the quality of the transmitted signal. So this is also similar with the noise that, for example, in a classroom, for example, when a teacher teach to the students and suddenly the students keep talking to each other, that one is also a noise, something like that. Okay, and for example, I teach in a classroom and you talk to your friends and you are actually creating noise that disturbs my voice. So when I transmit my voice to you in the classroom and you talking to your friends, you are creating the noise. The noise disturbs my transmitted signal and degrades the quality of my signals. And maybe students at the back of the class cannot hear my voice because of the noise. So that one is a similar concept like that. Okay, the noise, the thing that disturbs the transmission signal. Okay, so noise can exist within the transmitter and receiver. Okay, noise can exist within the transmitter and receiver within the system. So this is what we call as internal noise. Noise yang wujud di dalam transmitter dan receiver. We also have another noise, what we call as the external noise, that exists in the medium or the surroundings. Nampak So you will learn about the basic concept of noise. You will learn about the noise power, how to calculate the noise power. And you're going to see later that these noise affect the performance of the transmitted signal. The performance of the transmitted signal is what we is measured as a SNR. Okay, SNR, which is signal power to noise power. So this will be learned in the chapter 2. And then you will learn about noise factor F. You will learn about noise figure calculation in chapter 2. So this is chapter 2. Chapter 2. Okay. So chapter 2, most of the questions you will be asked about these parameters. Yang ini these parameters. So finish chapter 2, then you will learn about chapter 3. Chapter 3 is analog modulation. Okay, analog modulation, which consists of modulation process and demodulation process. Okay, so in chapter 3, the first part is amplitude modulation and demodulation techniques. Okay, for AM. So you will learn the process inside the transmitter. Okay, the process inside the transmitter. Inside the transmitter, we have a block diagram, a circuitry of what we call as a modulator. Modulator circuit. Sorry. Okay, we call it as a modulator. Apa itu modulator? Okay, modulator. So modulator is the circuits. Okay, it's a group of circuits that do the modulation process. Okay, so modulator. Okay, so here it consists of at least two input. The first one here is a message, VMT. The message, and another one we're gonna have carrier, VCT. Ni nantilah you will learn this later. So modulator will accept at least two inputs, the input message and also the carrier signal. Okay, and it will produce output. Okay, the first part you will learn about amplitude modulation, AM signal. Okay, AM signal. Okay, and you're gonna see later that modulation is the process of mixing input and also the carrier. So the purpose of the modulation is so that we can transmit the signal into the medium for long distance. Okay, one of the main reason to do the modulation process is so that we can produce an output signal over here that is suitable to be transmitted into the medium and long distance. That's one of the purpose of modulation. Okay, salah satu tujuan utama membuat proses modulation. Okay, and actually you're gonna see later that for modulation, okay, we can actually accept many inputs message. Okay, we can have many inputs and one carrier. So the carrier will carry all the input message together. It's some sort like a multiplexing and produce a AM also. Okay, so this is you can have many inputs and one carrier, or many inputs and many carrier. Boleh juga. Okay, but luckily in your syllabus you will only learn the basic. Okay, so if you see many input many carrier, that one is considered as high level modulation. Okay, but luckily in your syllabus you only will learn one input and one carrier only. Nasib baik nasib baik. Okay, so one input message, one carrier, very basic. Okay, so the first part is AM. That means you want to produce an amplitude modulation signal. So modulation is the process of changing the property of the carrier in accordance with the input message. So modulation ini, this process is a mixing two or more signal, but the mixing process change the property of the carrier signal. So what are the properties? There are three properties that you will learn. The first one is the amplitude property of the carrier. If the amplitude of the carrier change in accordance with the input signal, you will produce amplitude modulation at amplitude modulation signal at the output AM. Okay. Another one is frequency property. If the modulation change the frequency property of the carrier, then you will produce FM signal, frequency modulation output signal. So the third property is the phase, fasa. If the modulation process change the phase of the carrier in accordance with the input message, then you will produce PM signal, phase modulation signal. So you will learn this in chapter 3. So the first part of chapter 3 and then the second part of chapter 3. Okay, you will learn later that FM and PM are like twin brothers. Okay, they are related to each other. Okay, so AM, amplitude modulation, actually you can listen to AM radio. If you have a radio at home or you have a radio in your car, you can tune to the AM station. Normally we don't listen to AM station normally. Okay, biasanya kita tak dengar radio AM ni But you will learn we still can listen to the AM radio. Okay, maybe from radio from BBC for example, or other radio station for AM. So AM is considered as a medium frequency. Okay, range between 500 kilohertz until 1.7 megahertz. Okay, and we normally listen to FM radio. Okay, for example, we have a Hot FM, Surya FM, Era FM, Johor FM, and many others. Okay, So that one is considered as frequency modulation. Okay, so you will learn in chapter 3. And then this is a modulation process in the transmitter. But in the receiver as well, you will also learn a block diagram here, what we call as the demodulator. So demodulator will do the reverse process of modulator. Dia akan buat reverse process. Okay, dia akan buat reverse process. So that means you are receiving all of this. You are transmitting the signal AM, FM or PM signal to the receiver, and the demodulator will demodulate the receiving signal. It will do the reverse process. Okay, and you will see later that in the demodulator we also have a carrier signal in the demodulator to do the demodulation process. And the purpose of demodulator is to produce the original signal at the output. Okay, so here the original signal is a VMT, so we're gonna produce again VMT. Of course, when we transmit signal, we want to produce the original signal at the receiver side. Okay, so similar with your mobile phone. Okay, when I'm calling my friends, for example, I speak. Okay, I speak. So the voice, my voice is the input, the message. Okay, my voice is the input message. Okay, so my voice will be put inside this mobile phone, because this mobile phone consists of transmitter and receiver both inside. Okay, so my voice will be modulate with the analog carrier within the mobile phone. Okay, and this mobile phone will change my voice into a electromagnetic waves. But it is not AM, FM or PM, because this is a cellular system. Okay, cellular system is a high frequency. So that means this mobile phone will do the modulation process. It will convert my voice into electromagnetic waves and then transmit it into the channel or medium. And then the other side receive the signal and then demodulate the signal to get the original output. The original output is what? My voice. Okay, the other side will listen to my voice, not other voice. Okay, so that one is the demodulation process at the receiver, at the other side. Okay, so this you will learn in chapter 3, analog. So what does the term analog? Analog means that you are receiving, the input, the input to the transmitter is analog. Okay, the input to the transmitter is analog, and the transmitter process the input signal as analog, and the transmitters transmit the signal in the form of electromagnetic wave, which is also analog. Okay, you receive analog and you process as an analog, you produce analog. So this is an analog system. You process everything as an analog. What is analog signal? Analog signal is a continuous over time. Dia adalah signal berkadar terus dengan masa. That's chapter 3. Okay, so finish chapter 3. Okay, because you will learn a lot about this. So you in chapter 3 you learn the process inside the transmitter, which is the modulator, and then you learn the process inside the receiver, which is the demodulator. Okay, then finish chapter 3, and then move to chapter 4. So chapter 4 you will learn about digital system. You will learn almost the same process. You will learn almost the same thing like in chapter 3, but now it is in the digital system. Okay, so what's the difference? Okay, So the difference is for chapter 4. So this is I will write here chapter 3. Chapter 3. Okay. And then what? So maybe I can use a different color. I will use a yellow color. So in chapter 4, you will learn about digital. Okay, digital system. Of course, in digital system, we also have a modulator and demodulator in the receiver. Okay, you will learn a modulation process, digital modulation. You will learn digital demodulation techniques in chapter 4 as well. Okay, so what's the difference? So in chapter 4, you will see later that the input can be analog and the input can also be digital. Okay, input digital means in the form of logic 1 and logic 0. So the good thing, the beauty of a digital system is that we have the flexibility to have an input either analog or digital. And then the transmitter, okay, will do the modulation process and so on. Okay, so actually you're gonna have also modulation here. You can have also the modulation. You're gonna have also the modulator process. Okay, so in digital system, you will process the input as a digital data. Okay, so you see that you have the input, you have the options. You have the option to receive to have a analog input or digital input, and you process it as a digital. So what you process is a digital data. You process as a digital data. Then what? Then you have the option either to transmit as an analog or you want to transmit as a digital. Nampak? So you have the option, the first one, either you want to transmit as a analog or you want to transmit as a digital pulses. Normally when we want to transmit as an analog, we need to convert the digital data into electromagnetic wave and transmit it into the wireless channel. Biasanya, okay, normally like that. Normally when we want to transmit as an analog, we transmit it into the wireless channel in the form of electromagnetic waves. Okay, and then if we want to transmit as a digital, we need to convert the digital data into electrical pulses. Digital data is in the form of logic 1, logic 0, logic 1, logic 0. Okay, so if you want to convert into digital data, that means we convert into digital pulses. So we're gonna use a line coding. Line coding dipanggil sebagai line coding. So okay, so line coding converts digital data into electrical pulses. Because you have logic 1, logic 0, logic 1, logic 0. So how to change that logic 1, logic 0 into electrical pulses that is suitable for transmission? So that one needs to be done using a line coding, which you will learn in chapter 4. Okay, so you can transmit in terms of as a wired transmission, because digital pulses is a baseband transmission which normally transmitted across the wired channel. Okay, wired cable, normally like that. Okay, and if you want to transmit as a wireless, that means you need to do modulation with analog carrier. Okay, so you have digital data, you modulate with analog carrier. Okay, you modulate with analog carrier, and you produce at least three different kind of output signals. Either this one we call it as, so if the modulation process with the analog carrier, so now you see that you have digital data. Okay, this one digital data, you modulate with analog carrier. So what you will produce is, there are three possibilities. The first one is ASK, amplitude shift keying. So amplitude shift keying is similar but not the same with AM. amplitude shift keying is similar to AM. Similar, not the same, dia bukan sama. Okay, I told you this is similar from the perspective of this modulation change the amplitude of the carrier. So that's why we call it as ASK. And another one is FSK, frequency shift keying. Frequency shift keying is similar to FM, frequency modulation in analog. Similar, not the same. Okay. And another one is PSK. Okay, PSK similar to phase modulation, PM, but not the same. Dia bukan sama. Okay. So this one, if you want to transmit as a wireless, so that means you're going to have ASK, FSK, and also PSK. Okay, if you want to transmit as a wireless. Okay, then you're going to receive either, of course, if you transmit analog, you will receive analog. If you transmit digital, you will receive digital pulses at the receiver, and the receiver will process in terms of digital. Okay, the receiver will process in terms of digital, and at the output you have the flexibility to produce either analog or digital. Nampak? So this is the beauty of one of the beauty of the digital system. You have the flexibility to change from analog to digital, digital to analog. Okay, so if you want to know about one example. Okay, one example is your digital television. For example, like Astro. Example. Astro is a digital TV. That means the content is in the form of digital. Logic 1, logic 0, and so on. Okay, 10, 10, 10. But it is transmitted from the satellite to the Earth. Okay. So the satellite transmit the signal to the Earth in the form of electromagnetic waves. So that electromagnetic waves is this one. Okay, is a analog. Okay, Astro means that Astro has a digital data, so it transmit as an analog using electromagnetic wave from the satellite to the Earth. Nampak? So that's the one of the example. Another example is your mobile cellular phone. So cellular phone, the data is a digital, and we transmit as an analog in the form of electromagnetic waves. Okay, in the using a 4G LTE waves. Okay, which is a analog, but the data is digital. So you see the difference, right? Okay. So in the chapter 4, you will also learn about, of course, the term modulation and also encoding. Okay. So the word modulation and encoding are interchanged in the chapter 4, encoding and decoding. So encoding, decoding is a kind of modulation process that does not involve analog carrier. That one you also will learn about this. Encoding and decoding process is similar with the modulation, demodulation, but without the analog carrier, which you will learn later to produce the digital pulses. Okay, to produce the line coding. So this is you're gonna see later what you will learn is PCM, pulse code modulation. So pulse code modulation you will learn in chapter 4, and this is gonna be your second task in the project. Okay, about chapter 4. So nampak so chapter 4 you learn a lot the process inside the transmitter and receiver again. In chapter 3, you learn about the process inside the transmitter and also the process inside the receiver in terms of analog process. Similar, in the chapter 4, you will learn the process inside the transmitter for the modulation and also the process inside the receiver, which is the demodulation process. But in chapter 4, it is in terms of digital techniques. Nampak digital techniques. So this is chapter 4. Okay, so again I repeat, chapter 3 and chapter 4, you will learn the process inside transmitter and the process inside receiver. It is in chapter 3 and 4. Okay, and then what? So after you have learned a lot about the process inside the transmitter and inside the receiver, now you need to look from different perspective, from the outside of the system. Okay, so I go to the next part in chapter 5. Okay, so chapter 5. Okay, so I draw again. Okay, chapter 5. So I always tell the student, okay, that this is my favorite picture. Saya selalu beritahu pelajar bahawa this picture is my favorite picture. This one, the one that I draw now, I have drawn it in the previous slide as well. Okay, I always told the student that, hey, this is my favorite picture. Okay, later you will know why I always draw this picture during the class session. Okay, later you will know, because these are the scenario that will be asked in the final exam. Okay, so let's see the chapter 5. So chapter 5 is about three things: transmission line, antenna, and propagation. Transmission line is about the medium. Okay, the first part is transmission line. So transmission line is the topic about medium, transmission medium. Either it is a wireless, okay, either it is a wireless or wired medium. Okay, the first part of chapter 5, which is the transmission line, this is about the medium. Either the medium is wireless, the air, or it is wired using a cable. So you will learn the characteristic of the medium, the first part of chapter 5. The second part of chapter 5, okay, this is the first part, the channel, the medium. The second part is antenna, this thing. Okay, this thing. Antenna radiates the received signal into the wireless medium as electromagnetic waves. Okay, that means antenna receive the input from the transmitter and it will radiate the input as the electromagnetic waves into the wireless channel. So you will learn about antenna, the second part of chapter 5. Okay, and then what? After the second part of chapter 5, then you will learn about the third topics in chapter 5, which is the wave propagation. The characteristic of the waves, which is this one, the waves, sifat-sifat gelombang, which is transmitted across the channel. Okay, the wave propagation. What is the characteristic of the wave that propagates from one place to another? Sifat-sifat gelombang. That one is chapter 5. Okay. Okay, and that will listen. Okay, so I already write chapter 5. So you see that chapter 5, we are not looking the process inside the transmitter or receiver anymore. Instead, we are looking at the component outside from the transmitter and receiver. Okay, in chapter 5, we are not looking inside the transmitter and receiver anymore. We are learning about the things, the process happens outside from the transmitter receiver system. So this is chapter 5. So that's all for ECS. So you will learn all about that in one semester. Okay, so you see that if you ask me, there's a lot of things that you will learn. a lot of things you will learn in from chapter 1 until chapter 5, but it is more on the fundamental concept. Okay, ada banyak perkara, tetapi dia lebih kepada fundamental concept. It is not difficult, but you need to understand the process. Okay. So if you have question, feel free to ask me, no problem. Okay, boleh tanya soalan. Kalau nak tanya boleh, kalau tak nak tanya pun tak apa. Maybe you want to ask later. Okay. So that's all for I explain you in 2 pages. The first one I explain about chapter 1, chapter 2, chapter 3, 4, and then the last chapter, chapter 5, is about the outer process. That means that the process happens outside from the transmitter and receiver. Okay, and for your information, these chapter 5, especially the wave propagation, will be asked in the final exam. So it is one of the favorite question, okay, about the wave propagation. Okay, so ada soalan? Any question? Feel free to ask. Okay, so if you don't have question to ask, I will start with chapter 1. Okay, so hopefully you can be patient. Harap bersabar sebab kita akan mulakan dengan chapter 1. Okay, so chapter 1. So if you feel tired, if you feel boring or feel uneasy, you can go to anywhere. You can go to the toilet, you can go to your kitchen, drink water, walk around, and then please come back to the class. So for me, since this is an online class, I will not have a break. You can take a break on your own, and please come back again. Okay, because I will explain a lot of things, and whenever it is very important or will come out in the test or final exam, I will say that, okay, this is important, make sure you understand. So that one is a keyword for you to know that I am actually giving you some hints. Okay, biasanya kalau saya sebut ini penting, this is important, so that means there's a high possibility that it will come out in the test of final exam. Please make sure you take note about that. Okay, saya tak adalah kata oh ini masuk final exam. Okay, I will not say like that. Okay, I just say that okay, this is very important, you must understand about this slide, make sure you know about this, so it is very important, so you need to know about that. Okay, so let's begin with chapter 1. Okay, maybe 1 hour. Okay, maybe 1 hour from now, I will explain about chapter 1. Okay, so before that, class, are you still there? Can you see my screen? Can you hear my voice? Can
Yes,
anybody
Doctor.
respond?
Yes.
Okay, thank you for the response. So kalau penat boleh rehat sekejap kamu boleh rehat sendirilah. Okay, because if we do a face-to-face class, normally okay, during the face-to-face class before the COVID pandemic, normally I give a break in the middle of the class. Okay, normally between 10 to 15 minutes normally, but that one is a face-to-face. Okay, so now it's online, so you can do whatever you want. Okay, and make sure you come back here because there's a lot of things that you need to learn. Okay, so chapter 1, again, introduction. Introduction. So chapter 1 consists of 7 subtopics. Okay, introduction to communication system, terminology that been used for the communication system, the electromagnetic spectrum, about the frequencies, the bandwidth, how to calculate the bandwidth, types of electronic communication system, modulation and multiplexing process, and then about the power and decibel calculation. Out of all of these, okay, only this subtopic is about calculation. The rest is about theoretical concept. Okay, so maybe you will feel a bit boring about this concept, but I'm trying to explain the best, as best as I can, so that you can understand about the lecture session today. Okay, and later maybe next week we will learn about power calculations. Okay, so subtopic 7 is the favorite question that for sure will come out in the test and final exam. Okay, so introduction to communication system. Communication is the process of exchanging information from one point to another. Okay, the main barriers are the language and the distance. Okay, so when we want to design a communication system, that means we want to send signal in a long distance. Okay, tujuan kita buat communication system ini supaya kita boleh hantar signal. We can send the signal long distance. If it is a short distance, you can just shout to another place. The other place will listen like that. So the purpose is for long distance, okay, with various types of data that we can transmit simultaneously. Okay, so the contemporary society emphasis on how the accumulation of accumulation, packaging, and exchange of information. Of course, we want to transmit signal, many signal together from one point to another. It should be efficient, reliable, and secure. Okay, these are the targets that we want to achieve when we want to design a communication system. Okay, dia mestilah efficient, reliable, and secure. So it requires transmitter, channel, or medium, and also the receiver. So these are the three things, the three main components of the communication system. Okay, so during the communication process, noise degrades or interfere with the transmitted information. Ini dia, the noise, which you will learn in chapter 2 later. Okay, and this is a basic block diagram. Okay, this is the basic block diagram of communication system, which consists of transmitter, and here is the source. So here in this block diagram, it separates the source and the transmitter, because the source provide the input to the transmitter. The transmitter will convert the input into a signal that is suitable for transmission across the medium. Okay, so tujuan transmitter ini untuk menukar input kepada signal yang sesuai untuk penghantaran jarak jauh. Okay, that's the job of transmitter. So it put inside the medium. So the medium can be wired or wireless. Okay, then the receiver receive the signal. Okay, the receiver receive the signal from the medium, and it converts into the original signal and then send to the destination. So this source and destination is like two people communicating to each other. Okay, for example, I'm calling you using a mobile phone. So I'm the source, you are the destination. Okay, so the system transmit my voice through the channel and then to the other side, and then you can listen to my voice. Okay, and then what? So this example B. So this example B is for the internet system, which is what we call as the request and response communication. So it is a communication between the computer and a server. Okay, so what happened is that normally when we want to, for example, browse a website, for example, we browse to UTHM website, we click, so we write www.uthm.edu.my. So this one, that means we are requesting data to the server. Okay, it goes through the modem. Modem will do the modulation process and then go through the networks and then modem for the demodulation process put inside the server. So that means the server receive a request from a computer somewhere in the network. Okay, so the computer request to browse, for example, the UTHM website, and then this server will response, and then through the modem modulate, through the networks, go to the modem, demodulate, and then go to the workstation. So the workstation or the computer will receive the web page of UTHM website, something like that. So this process happens frequently, request, response, request, response. So this is about the internet communication system, okay, which involve a request response to the server. And this is the general block diagram of a transmitter and receiver. Okay, so if you see from here, the input here is a signal source. Okay, for example, my voice. Okay, so starting from here is the transmitter system. Okay, starting from here is the transmitter system. So transmitter will convert it, the input voice into a baseband converter. So baseband is a low frequency signal. Okay, base frequency ataupun frequency dasar, base. Okay, so if you see from the graph, spectrum graph, it is starting from 0 until a few kilohertz. Until a few kilohertz of frequency. So this is categorized as a baseband frequency. So this can be voltage or power. Okay, so this is a baseband. Okay, and you will see later a term what we call as a band pass. So maybe I delete this one. Yeah, you will see later that there's a you will see the term band pass. Okay, what is band pass? So the term band pass frequencies, so that one is high frequencies. Okay, so this is not a baseband, this is a band pass frequencies signal. Okay, it is a high frequency signal which has a wider bandwidth. Okay, so that one is the terms that you will learn later. Okay, so let's look here. The baseband, that means the transmitter will convert it into a baseband signal and then put inside the modulator. So the modulator will do the modulation process and then amplify the signal, power amplification. Why we need power amplification? So that we can transmit at a longer distance. After we do the modulation, we increase the power for the purpose of transmission. Okay, and then if you see here, subsystem synchronization. Okay, so subsystem synchronization normally inside the digital system, normally inside the digital transmitter, normally, because synchronization is the process of synchronize between the transmitter and receiver in terms of time. So in digital system, the transmitter and the receiver needs to be synchronized in terms of time for transmit and receive. Okay, the receiver needs to know when the transmitter want to transmit data. Okay, so they need to be synchronized in terms of time so that they can transmit a lot of data at a certain required parameters, require a certain limitation of parameters. Okay, so the transmitter needs to know what is the limitation of the receiver. Okay, so that it will not transmit too fast or too big of the data. Okay, this is the synchronization between two parties. Okay, that one is in the digital system, but in the analog normally we don't have the synchronization process. Okay, so after modulation you will produce electromagnetic wave. So I believe that this is transmitted in term of analog into the wireless medium. So this goes to the receiver. Okay, so when the signal travel from transmitter to the receiver, it will travels in long distance. So what happened when the signal travel long distance? The signal will attenuate due to the distance or due to the crash with the obstacles. Okay, apabila signal itu bergerak daripada transmitter ke receiver, ia akan attenuates. Attenuates means perlemahan. Perlemahan disebabkan oleh salah satunya adalah because of the distance. The other reason is due to the crash with the obstacles. Pelanggaran dengan halangan antara transmitter dan receiver. So the obstacles can be, for example, trees, buildings, okay, or what they call the air particles, the raindrops, and so on, many others. Okay, so it will attenuate the transmitted signal from the transmitter to the receiver. So what happened when the signal arrive at the receiver? The signal will be in low energy or low power when it arrives at the receiver. So therefore, the receiver needs to amplify the input, okay, and then do the demodulation process. Demodulation is the reverse process to get the original baseband signal, and then from here it converts the baseband into the output, okay, and then baseband processing and then get the output. Again, subsystem synchronization is to synchronize between this transmitter and receiver. Okay, it needs to synchronize in terms of time. So that one is a digital system. Okay, terminology. Term electronic communications. When we talk about electronic communication, it must consist of transmitter, receiver, and also the channel. Okay, so transmission, reception, and processing of information between two or more locations using electronic circuit. Information, okay, is a commodity produced by the source for transfer to some user at the destination. Okay, message is a physical manifestation information as produced by the information source. So how to describe this? Information, for example, when I speak, okay, when I speak, for example, I'm teaching right now, I'm producing a message. I'm producing a message from the source. Okay, so my message consists of information. So I'm the source. I produce a messages that contain information. The information is what I'm teaching right now, the content of my teaching. Okay, so how I want to send this message? If I just using my voice, maybe you at your home, you cannot listen to my lecture. Okay, so that's why we use a Google Meet. I need to convert my message, the voice, this voice, into a something that can be transmitted across the internet system and then to your place. So my message need to be changed into signals. Nampak So the message is converted into signal that is suitable for transmission across the medium. So that the thing that travel across the medium is what we call as the signals. Okay, benda yang bergerak dalam medium itu yang dipanggil sebagai signals. Okay, so signals are physical embodiment of information. It is in the form of voltage signal or current signal. Okay, ini nanti kita akan lihat. So types of signals. This one. Type of signal. So the first one here is the analog signal. You see that analog signal is continuous over time. Dia berkadar terus dengan masa, and it has an infinite shape. Okay, dia tidak ada satu. There's no specific shape for the analog signal. It is infinite. Okay, pelbagai. Okay, different from the digital. So digital signal has two possibilities, either logic 0 or logic 1. Okay, logic 0 or logic 1. Okay, so digital signal has two possibilities, either logic 0 or logic 1. Regardless of any digital signal, it only there's two possibilities only, logic 1, logic 0. Different from analog. Analog has infinite shape. Nampak eh? So you see that the good thing about digital is that all signals are the same. Only two possibilities, logic 1, logic 0. So what's the good thing is that if we use digital, easy for us to combine many signals together and to process the signals. Okay, you see that the signal for digital signal only consists of two possibilities, logic 1 and logic 0. So all signal logic 1 and logic 0 for the digital. That means I can multiplex, I can combine many signals together, and I can send the signal, the combined signal, simultaneously at one time. So, okay, that one is a multiplexing process. So that's the beauty of digital. We process all the signal in the same manner, because there are only two possibilities, different from the analog. It has infinite shape. Okay. Terminology, transmitter, TX, collection of one or more electronic devices or circuits that converts original source into a signal that is more suitable for transmission over the transmission medium. Okay, so what is the electronic device or circuits? Consists of modulation circuits, coding circuit, mixing circuit, and translate. So this is the process that happens inside the transmitter. Another function is amplification by the amplifier, filtering process, and also radiation by the antenna. So message convert into electrical signals by transducers. And then what? The receiver receive the signals from the medium and then converts them back to their original form through a few processes, which is mixing, demodulation, decoding, and so on. Also involve amplification and filtering process, of course. Okay, transducer convert the electrical signal at its input into a form desired by the system used. For example, we are talking through the phone, mobile phone. So I'm talking, this transmit the signal to the medium. You at the other side receive my signal from to your mobile phone. The mobile phone converts into a voice, which is my voice. So you can listen to my voice. Okay. Modulation. See this one? Modulation is a process of changing one or more properties of the analog carrier in proportion to the information signal. So what are the properties? So I've explained earlier that there are three main properties. Okay, the first one is the amplitude. Okay, if the modulation process change the amplitude of the carrier, so we will produce amplitude modulation signal. And then frequency. If the modulation process change the frequency of the carrier, then we will produce FM signal, frequency modulation signal. Then the third property is the phase, phasa. So if the phase of the carrier change in accordance with the input message, then we will produce PM, phase modulation signal. So you see that this one. In digital, okay, in digital, this one is for amplitude is what we call as the ASK, FM, For frequency properties is what we call FSK, and for the phase property is what we call as a PSK, phase shifting, frequency shifting, and amplitude shifting. So this one is for the digital, and this one on the left here, AM, FM, and PM, is for the analog in chapter 3, and here on the right is chapter 4. Okay, so why do we need to do modulation? Modulation we need to do so that we can change the input signal into we change the input message into a suitable signal for transmission. Normally when we do the modulation, we are actually translating a low frequency input into a high frequency output so that we can transmit into the wireless medium as a radio wave. Itu proses modulation. So modulation helps to change the input into a suitable signal for transmission for long distance transmission. That's the first reason. The other reason is that we do modulation. The other reason is that we do modulation. So that we can use a small components of antenna, for example like your mobile phone. Okay, later you will see that modulation helps us to use a more compact design of system. Okay, because we change low frequency into high frequency. Later you're going to see that if we use a high frequency, okay, we will produce a smaller lambda signal. Okay, smaller lambda signal. So modulation convert low frequency to high frequency, and the good thing is that when we use a high frequency, we will use a small antenna design. For example, like your mobile phone. For example, like mobile phone, antenna is very small inside this mobile phone. Because I'm using a 4G LTE signals, so the frequency is more than 900 megahertz. Okay, above a 900 megahertz. So because of that high frequency, the size of the antenna becomes smaller. So I can use a more compact device like this. Okay, there's a modulation. And another good thing about modulation is that we can multiplex many signals together and transmit at the same time for multiplexing. Okay, and then modulation also important for the data reliability and security and so on. So there are many advantage of the modulation process. Okay, and for your information, modulation was the question that have been asked to me during my job interview in Flextronic company. You know Flextronic company, Flextronic. So a long time ago, I went to the job interview in Flextronic. Okay, and one engineer asked me, could you please explain to me about modulation? What do you understand about modulation? Okay, so I explained, I don't know whether it is correct or not at that time, but actually what he want to know is how I understand about this process. Okay, very simple. He asked me about this. Okay, so this is from my past experience, been asked during my job interview. Okay, just to know about my understanding. Okay, the question is simple, but the answer is difficult. Okay, okay, and then what? Mixing. So mixing, you mix at least 2 or more inputs. You mix. So what's the difference? Modulation is also a mixing process, but mixing, you just combine without changing the properties of any of the input signal. Dia tidak melibatkan perubahan sifat. just combine. Later you're going to see that mixing is actually the process of addition or multiplication in mathematics. Okay, secara matematiknya dia akan melibatkan proses tambah dan darab. Nanti you akan lihat. And then what? Filtering. Filter. We remove the unwanted frequencies. We remove the unwanted signals. We filter out. Okay? Kita nak buang sebahagian signal yang tidak diinginkan. Okay? And then what? Baseband converter. To convert the signal source into a baseband, base frequency dasar, for carrier signal before transmission. Can be either analog or digital system. Subsystem synchronization is to synchronize between the transmitter and receiver for recovery process. Recovery is for the process inside the receiver to produce the original signal. So both transmitter and receiver must synchronize each other. Okay, so that the receiver able to demodulate or to decode the received signal into the original signals. Okay, and then what? Transmission medium. Of course, we have two categories: wired or wireless. So wired, normally we use the term guided medium. Wireless medium we refer to unguided medium. Nanti kita akan lihat. We're going to see later that one. Okay, so medium can be wired or wireless. Okay, so wired can be copper wire, optical fiber, and any type of cables for transmission. Okay, and for the wireless we refer as a free space. Okay, where we can transmit the electromagnetic wave. Okay, and this is the characteristic of electromagnetic wave. So if you see from here, you see that electromagnetic wave consists of two what they call two fields, electric fields and magnetic fields. Okay, ada dua medan, medan elektrik dan juga medan magnet. Okay, both electric field and magnetic field are perpendicular to each other. Okay, their oscillation axis, okay, both oscillates at 90-degree angle. If you see from this picture, okay, the E field and the B field oscillate at a different axis. Both of them are perpendicular to each other, and both of them move together in a different axis direction. Okay, perpendicular to the oscillation. Okay, they are moving at a direction perpendicular to the oscillation axis. Pergerakan adalah pada paksi yang 90 darjah daripada ayunan. Okay, these are the characteristic of the electromagnetic waves. Okay, so frequency range from 200 kilohertz until a few gigahertz. So normally we use this is categorized as a radio wave or microwave. So when it goes to the upper frequencies, that one is considered as a microwave. Okay, so between 200 until a few gigahertz, that one is considered as a radio wave. So we will see later about this. Okay, frequency is the number of motion occurs in a period of time. Okay, it is is the number of oscillation within one cycle. Okay, how many oscillation have been done within one cycle? Berapa banyak repetition? How many repetition has been done within one cycle? So one cycle, the time is what we call as a period of time, T time. Okay, so one period of time is equal to 1 over frequency, because frequency is 1 over second. Okay, frequency is 1 over second. So if you divide 1 over frequency, you will get the period of time in term of second. Okay, T is in term of second. Cycle is one complete alternation of waveform. Okay, so what is cycle? For example, like a sine wave. Sine wave. one cycle. I think you know, I believe you know about this. This is a sine wave. This is one complete cycle. Okay, and this cycle continues again for the next cycle. Okay, the second cycle, another T, and so on, dan seterusnya. Okay, one complete cycle. So the wavelength, panjang gelombang, lambda, is the distance traveled by the electromagnetic wave during one period. So within one period, how long does the wave has traveled? Within one complete second. Okay, so wavelength defined as the distance in meter that the wave has traveled within one complete cycle. Berapa jauh gelombang itu telah bergerak dalam masa satu kitaran lengkap. Okay, so lambda, you see that lambda here is equal to c over f, speed of light divided with the frequency of the wave. Okay, c, speed of light, is equal to approximately equal to 3 times 10 power of 8 meter per second. Okay, meter per second. So this one is in term of meter. Okay, and this is the designation of frequencies, the range of frequencies, and also the lambda. So you see that the frequency, okay, the frequency move from low frequency into a higher frequency. Okay, and the lambda, when the frequency becomes higher, the lambda becomes smaller. Okay, so frequency becomes higher, lambda becomes smaller. Why is it like this? Because lambda is equal to c over f. Okay, the higher the frequency, the lower would be the lambda. The lower the frequency, the higher would be the lambda. Inverse, so dia akan inverse. So this is the designation of the frequencies group. ELF is the extremely low frequency. Voice frequency, very low frequency. Low frequency, medium frequency. Medium frequency is used for the AM. Okay, AM is between 5 6. AM is 5-6 kilohertz until 1.7 megahertz. Okay, that's AM. And then high frequency, and then very high frequency. So very high frequency we can use for the TV broadcasting and also for the radio broadcasting, which is FM and also the PM radio. Okay, so I think, wait, I heard something. Maybe your friend is coming to the class, is it? I don't know. Sorry. Someone request to come to the class or what? Okay. Okay, UHF is ultra high frequency, super high frequency, and extremely high frequency. Okay, and these are the what they call the applications of the frequencies. For example, extremely low frequency, very high frequency, and voice frequency and very low frequency. This one is using in the power and telephone system. And this is also used in the twisted pair cables. Okay, and then if you see from the medium high to the very high frequency, it is used in the radio systems. Okay, radios and television broadcasting, electronic tubes, integrated circuits, cellular telephony. And this is also used for the coaxial cable. Okay, and if you see that these are the applications for the AM radio, for the medium frequency, very high frequency for the FM radio and TV broadcasting. When you go to the high frequency, The application, it is under the category of microwave frequency. It is used in the radar, microwave antennas and magnetrons, and also for the satellite communication system. And then if you go higher, it is for the infrared, for example, like lasers, guided missiles and rangefinders. And if you move to higher frequency, it is categorized as a visible light frequency. What is a visible light? Visible light means that you can see the wave. You can see the light. For example, like the LED light or your light in your room, that one is a visible light. Okay? But visible light here is used in the LED system, light emitting diode, which able to transfer the data, which is used in the optical fiber system. Okay, I think you have heard about Li-Fi. Light it's a Wi-Fi, but it is used as a light, visible light. It is called as a Li-Fi. So Li-Fi is a new technology, but not yet commercialized in Malaysia. It has been used in other countries, where it is like a Wi-Fi, but it is using a LED light. So the Li-Fi is a high-speed transmission Wi-Fi, okay, using the optical system, but it has a smaller coverage area compared to Wi-Fi. Okay, Wi-Fi that we use now at home, okay, it has a wider coverage area. But for Li-Fi, using a visible light, the coverage becomes smaller because of high frequency. Remember lambda, lambda becomes small, so the coverage becomes smaller, but the speed is very high. Okay, so within one room we might need a few Li-Fi routers to cover a wide area of rooms. Okay, so that one is the applications. And this is also the analogy of the wavelength and also the frequency. So you see that the higher frequency to the right, and then the wavelength becomes smaller. Okay, and you see that here, as the frequency goes higher from 10 power of 6 until 10 power of 20. So at this low frequency, okay, this is 1 mega, so it can be used for the AM radio, okay, and also other types of application over here. And you see that the wavelength is the size of soccer field or house, so big, very very long wavelength. And when the frequency goes higher, the wavelength becomes smaller, and the size becomes like a baseball for microwave frequencies, and then this period dot here for microwave frequencies. And then for infrared frequencies, the size of the lambda is very small, like a cell, until it is like a water molecule like this. Okay, and the applications for high frequency, for example, like this is above the visible light. Previously we see the visible light. After the visible light, ultraviolet, soft x-rays, hard x-rays, gamma rays. So the highest here is gamma rays. So gamma rays, very high frequency, and the wavelength becomes very small. Okay, and I already explained about this terminology. You can read on your own this medium frequency, high frequency terminology. Okay, we have seen this one previously. And then the bandwidth, this is important. So bandwidth defines the frequency spectrum. Okay, bandwidth defines the frequency spectrum, the range of the frequency spectrum. Okay, it is a portion of electromagnetic spectrum occupied by the signal. So frequency range over which receiver or other electronic circuits operate. So how we calculate the bandwidth? We must minus the highest frequency to the lower frequency. So we subtract high frequency, the highest, to the lowest frequency. For example, like this one. Okay, the frequency band from F1 300 Hertz until F2 3000 Hertz. So within this we have a lot of frequency spectrum used for the communication system. Okay, inside here consists of signals that we use for transmission. So now the question is, how much is the bandwidth for this frequency band? So in order to calculate this, so we need to know how much is the highest frequency and how much is the lowest frequency. When we know both numbers, then we can subtract. Bandwidth here is measured as F2 minus F1. So F2, the highest frequency is 3000 Hertz minus the lowest frequency is 2700 Hertz. So you get, 3000 Hertz minus 300 Hertz, the lowest. So you get 2700 Hertz of bandwidth. Remember, the unit for bandwidth is in terms of Hertz. Okay, bandwidth defines the range of frequencies used for the transmission. Okay, so channel bandwidth, range of frequency required to transmit the desired information. So for example, if I want to transmit signal, I'm not using a single frequency only. There might be another frequencies as well. Okay, so the distance or the range of frequencies define the bandwidth or the channel bandwidth that used in the transmission. Okay, and then what? Transmission medium. Okay, so transmission medium. So transmission medium, which is or what we call as a channel. As I said previously, there's a two category: wired or wireless. So wired is what we call is a guided medium. We call it as a guided transmission medium. Okay, so guided transmission medium or wired medium. Why it is guided? Because the term guided here means that the signal is guided from one place to another in a specific way, in a specific path. Okay, so in order to guide the signal, actually we are using a cable, any type of cable that is suitable to carry the signal. Okay, for example, here is a coaxial cable, twisted pair, fiber optics, waveguides. Okay, and then the second types is unguided. That means this is referring to the wireless medium. Why it is unguided? So the term unguided means that the signal from the transmitter is unguided towards the receiver. That means from the transmitter the signal can go in various paths in order to arrive at the receiver. Okay, it will arrive at the receiver, but it will move in many directions. Okay, that one is a wireless. Okay, so characteristics and quality determined by the medium of signal. For guided, medium is more important. For unguided, the bandwidth produced by the antenna is more important. The key concerns here is the data rate and distance. Okay, of course, for wireless transmission, bandwidth is important. Okay, because for wireless communications, bandwidth is very limited. Okay, for certain type of application, bandwidth is very limited. So what is the example? Example is your cellular communication, cellular mobile. So this one is using a GSM or 4G LTE or 5G, for example, where the bandwidth for each telcos are very small, which they need to accommodate millions of users. Okay, so in a short, bandwidth is money. Okay, so that's why, for example, like your Unify, your home broadband, if you see that the telco plays around with the bandwidth specification, the higher the bandwidth, that you request, you need to pay more. So bandwidth is related to the speed as well. Okay, the higher the bandwidth, that means you can achieve faster transmission. For example, like Unify, the home broadband, for Unify 100 megabit per second, and compared to Unify 500 megabit per second, so the price is difference. Okay, so 100 Unify 100 requires smaller bandwidth compared to Unify 500. So because the speed is proportional to the bandwidth. Okay, so that's why when you want to get more bandwidth or more speed, you need to pay more. Okay, so that's the issue about the bandwidth. Okay, characteristics of wireless propagation. This one also have been asked in the previous final exams about the characteristic of the waves. Okay, there are three characteristics how the waves travel across three different kind of routes. So you see that line of sight, sky wave, and ground wave. So let's move. Let's see for the first one. Line of sight means that it is within the line of sight of our eyes. Okay. So for example, here we have two transmitter and receiver base station, for example. Okay, so we have seen this. There are a few of these inside the UTHM campus as well. Okay, so for example, here these two are communicated to each other, and between these there should be no obstacles. There should be no buildings or trees or any other obstacles that stops or that disturb the line of sight. It must be a clear path from one place to another. So normally this one is, for example, the system of FSO, free space optic. Okay, free space optic, for example. Here in UTHM we have a FSO. For example, we have the base station that connects the main campus and the students' residential place. Okay, so we have a tower that communicates from main campus to the residential using the FSO, free space optics. Okay, and then what? This one is for 30 megahertz and above. And then for skywave, we send the signal to the atmosphere, to the ionospheric layer. So what happened is that this is for the long distance communication. Skywave is for long distance communications where we transmit the signal to the ionospheric. Okay, normally this is for the TV broadcasting, and you see that the signal is transmitted to the ionospheric. This is ionospheric. Okay, and then the signal will be reflected back to the earth. Okay, this is ionospheric. Another one is what we call as a ground wave. So ground wave, before that sky wave using a low frequency. Okay, using a low frequency. Why low frequency? Low frequency can travel long distance. Okay, because the lambda is higher. I'm not saying that high frequency cannot travel long distance. No, no. So normally for this broadcasting long distance, we use a low frequency, mainly due to the lambda size of the lambda. Lambda is higher. Okay. Ground wave. Ground wave is normally for the this base station that send the signal towards the Earth's surface. For example, here you have a base station. Okay, so this is the Earth's surface. Okay, for example, you are here. Okay, so this base station sends the signal to the ground wave like this. Okay, so this is what we call as a ground wave. Okay, and frequency up to 2 megahertz, for example, like AM radio broadcasting, for example. Okay, So ground wave also used for the cellular phone, depending on the frequency type. Okay, so you see that these three types has been asked in the previous final exam, where students have been asked to explain about these three different routes, ground wave, sky wave, line of sight. Okay, ni pernah ditanya. It has been asked in the previous final exams. Okay. Transmission impairment. This is also favorite question. Okay, has been asked many times in the test and exam. So impairments is any undesired effect on the signal while traveling from transmitter to the receiver, such as noise, attenuation, interference, and other losses caused by the atmosphere or the medium itself. Okay, and impairment in the analog system, it will show the degradation of the signal quality, while impairment in the digital system, it will cause a bit error. Okay, so signal quality, it is SNR. Okay, one of the quality parameter is SNR. Salah satu daripada parameter quality adalah SNR. Bit error, so bit error is like this. When transmitter send 101010, for example, suddenly the receiver interpret this message as 111010. So you see the difference here is that this is what we call as a bit error. It's supposed to be 0, but the receiver interpret this as logic 1. So this is what we call as a bit error. Okay, so impairment can caused by three factors: attenuation, noise, and interference. And then what are them? Okay, so these are the questions that have been asked many times in the test and final exam. So you can see that this is our favorite question. Explain the transmission impairment. There are three: noise, attenuation, and interference. Noise is a random, undesired electrical energy that enters the communication system via the circuit devices or communication media and interferes with the transmitted message. So this is the keyword here is undesired electrical energy. And then what? Attenuation. Attenuation is a drop of signal power due to the distance when the signal travel from one place to another. Attenuation, what we call in Malay is perlemahan signal disebabkan oleh distance. Okay, and then what? Interference. Interference is also part of noise. Interference is also a noise, but it is a noise that has the same frequency as your signal. For example, I'm transmitting signal at 100 megahertz. You also transmit signal at 100 megahertz. So what happened is that the signal will mix up. Okay, and what happened? The receiver will be unable to demodulate the signal. Okay, because the signal has been mixed up. The receiver will be unable to differentiate about the mixing signals. Okay, at the end you're gonna get a mix up signals, like a noise, something like that. Okay. Bit error rate. So this is how we bit error rate is another significant measure of system performance in terms of noise is the bit error rate. So this is normally used in the digital system. It specifies the number of bits that are corrupted or destroyed as the data transmit from transmitter to the receiver. So how we write the bit error rate, how we dictate the bit error rate. So the bit error rate is written in the form of 10 power of minus x. Okay, 10 power of minus x. X shows how many bits, how many corrupted bit within the transmitted bit. For example, 10 power of minus 6 indicate that 1 bit out of 1 million bits is corrupted in the transmission. Okay. For example, another example, 10 power of minus 3. That means 1 bit out of 1000 bit are corrupted in the transmission. Okay, so for example, here you have 10 minus 6, we have 10 minus 12. Okay, so 10 minus 12 is 1 bit out of 10 power of 12 bits sent will be corrupted. So you see that bit error rate, we want the parameter to be as low as possible. The lower the bit error rate, the better will be the quality of the transmitted system. Okay, so you see that from this notation, the higher the magnitudes, okay, the lower would be the, okay, the higher the magnitude, the lower would be the bit error rate. Why? Because this is 1 bit out of 10 power of 12 bit will be corrupted. This one, 1 bit out of 1000 bit will be corrupted. So you see the difference. Okay, within 1000 bits they're gonna be 1 bit corrupted, but this one, 1 bit out of 10 power of 12 bits will be corrupted. So that means the higher the magnitudes, the lower would be the bit error rate, which is will be better. Okay, ideally we want the bit error rate to be as low as possible. Okay, we want the magnitude to be more than 12, the best. Okay, of course we cannot make it 0. Okay, bit error is normal to happen inside the digital system. Okay, bit error ni biasa memang akan berlaku, cuma kita mampu untuk mengurangkan kadarnya. Okay, we just want to reduce the rate. Okay, so several factors that contribute to the bit error rate. For example, here is the bandwidth. Okay, the lower the bandwidth, the lower will be the bit error rate. Transmission speed, so bandwidth is in terms of hertz, speed is in terms of bit per second, BPS. Transmission speed. So the lower the transmission speed, the lower would be the bit error rate. And then the type of transmission medium, the environment, what kind of obstacles within the environments, that one also dictates the bit error rate. The distance, the longer the distance, the higher would be the possibility of the bit error rate. And then the transmitter and receiver performance. Okay. Types of electronic communication system. You can classify electronic communication into three types. There are 3 types. Okay, there are 3 ways to classify the communication system. Ada 3 cara untuk mengklasifikasikan sistem komunikasi. The first one is the transmission mode. Okay, second one is analog or digital. Okay, before this I explained as analog or digital. Remember my jam board, my whiteboard previously I explained that analog in chapter 3, digital in chapter 4. This also there is a way. It is a way to classify the system, analog or digital. We can also classify in terms of transmission mode, one way or two way. Okay, ada pelbagai cara untuk mengklasifikasikan communication system tersebut. Okay, we can also classify the communication system either baseband or broadband. Okay, so if we look from the first part, transmission mode, if we can classify the we can classify the communication system in transmission mode, in terms of transmission mode. So transmission mode can be divided into 2 parts, one way and two way. So one way is simplex, what we call as a simplex. That means signals travel in one direction only. Okay, so this is normally used for the broadcasting. Okay, so for example, like television or radio, you only listen the radio, you only see the television one way. You are not talking to the radio station, right? You only listen to the radio station. So the signal travels one way towards your direction. Okay, so that one is a simplex. Two-way is a duplex. So two-way can be divided into two, half duplex and full duplex. Okay, so half duplex means that both parties can talk to each other, but only one at a time. Okay, so that means the signal travels in one direction at a time. Okay, both parties can talk at the both parties can communicate to each other, but only one at a time. So an example is like a walkie-talkie. Walkie-talkie, you know walkie-talkie like the police walkie-talkie, or for example ambulance and so on. So when we speak through the walkie-talkie, the other side will listen, and when the other side talk, we need to listen. So only one way at a time. This is what we call as a half duplex. And then we have another one is a full duplex. So full duplex, both signal can travel in both directions simultaneously. For example, like your mobile phone, your phone. So we can speak at the same time. Okay, when I call you, we can speak at the same time. So when you speak, I can listen. I speak, you can listen. So this is the full duplex. Okay, and then another one is how we can classify the communication system is by categorize the communication system into two. This is what I have explained previously: analog system or digital system. Okay, so analog system, energy is transmitted and received in analog form. That means if you see that transmitter, okay, so you receive a signal as analog, you transmit signal as analog, okay, and then you receive analog, and then you produce output as analog. So this is analog. Okay, and then what? Digital system. So digital system can be, it is categorized into two. The first one is digital transmission. So this is using a digital pulses. Okay, it uses a digital pulses between two or more points. It does not involve analog carrier. That means it is using a baseband transmission. Okay, baseband transmission. Tidak melibatkan modulation dengan analog carrier. So these normally use the electrical pulses. That means, okay, that means we are transmitting normally we are transmitting this baseband using a wired transmission line. Okay, normally we use wired transmission line. Okay, because we are not converting it into a radio wave because there's no analog carrier. So original source may be in digital or analog. Okay, so that means original source, of course we have the options to have analog or digital original source, and we can produce analog or digital. Okay, if analog signal convert into digital pulse prior to transmission and converted back, this one converted back to analog, it requires physical medium between transmitter and receiver, which is cable. Okay, another one is digital radio. So the keyword here is radio. That means we are transmitting the signal as a radio wave. Okay, kita hantar menggunakan radio wave. So here that means we do the modulations with analog carrier. Okay, that means in the transmitter we will inject the carrier, okay, and we will transmit as a radio wave. Radio wave means that analog. Okay, so that means the input, again the input can be analog or digital, but we do the modulation with analog carrier. So we transmit as an analog, okay, and then we receive analog in the receiver, okay. Receiver will process this as a digital, and you have the options, either you want to produce analog or you want to produce output digital. Okay, so the keyword here is digital radio, means that you are modulate the input with analog radio wave, which is the carrier. Okay, so transmission medium in physicality of free space. So as I say that, normally in the free space, pada kebiasaannya adalah free space. It can also be wired, but that one is a different category. Okay, so advantage of digital transmission, of course, it is in terms of technology, it is a low cost VLSI technology, data integrity, longer distance over low quality of lines, capacity utilization, that means we can do multiplex of many input signals, because the signals are the same in the form of logic 1 or logic 0. So if I use a digital system, I can multiplex many signals. I can utilize I can utilize the capacity to the best I can. That means I can fully utilize the capacity at high capacity. We can transmit together many signals together. So this is referring to the multiplexing. Okay, kita boleh multiplex many signals together. In terms of security and privacy, of course, we can do the encryption only in the digital system. And then the beauty of a digital system is that we can treat analog and digital data similarly. That means we can have input or output as a digital or analog. Okay, the last one. Okay, we can also classify the communication system in terms of baseband or broadband. Okay, so baseband, so this is the third part. That means kita boleh classify communication system itu sama ada secara baseband transmission ataupun broadband. Okay, so baseband transmission means that you are putting the original signal directly into the medium. That means no modulation. Okay, no modulation with analog carrier. Okay, analog carrier. Tidak ada modulation dengan analog carrier. So you are transmitting at a base frequency ataupun frekuensi dasar, frekuensi yang rendah, low frequency. Okay, so digital signal are used, but it can also be used with analog technologies. Frequency division multiplexing is not possible because we are using baseband transmission. Baseband is a bidirection, short distance traveling. Entire bandwidth of the cable is consumed by a single signal in a baseband transmission, low frequency transmission. For example, Ethernet. Another one is a broadband transmission. Broad here means that bigger bandwidth. Okay, the term broad here means bigger bandwidth. Okay, original signal is used to modulate the carrier. So you see that we modulate with carrier, with analog carrier. Then we transmit. We do the modulation with analog carrier first, and then we transmit. So analog signal are used. Okay, transmit of data is unidirectional. Signal travel long distance. Frequency division is possible because you are using a broadband. Okay, broad bandwidth. Okay, example is digital subscriber line and cable television networks. Okay, and that's all for today. I will explain about this next week. Okay, so you can open your QR code. Okay, you can open your QR code to scan your attendance. Okay, so semua boleh open QR code. I will open the attendance system. Okay, siapa yang masih tertidur boleh bangun sekarang. Okay, so now I will open the QR code. So open your SMAP QR code reader. So after you have scanned your attendance, you can go out. Okay, you can go to anywhere you want. Okay. So I will open. Wait. So ready? You can scan your attendance for today. Okay, this is the QR code. So you can scan your attendance and then go out. See you again next week. Okay.
Thank you, Doktor.
Okay, welcome.
Terima kasih, Doktor.
Okay, sama.
Thank you, Doktor.
Welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome. Salam.
Thank you, Doktor.
Thank
Okay,
you, Doctor.
welcome.
Thank you, Doctor.
Okay, welcome.
Doctor, I cannot scan, Doctor.
Ya, me too, Doktor.
Okay, welcome. Siapa tak boleh scan?
Saya.
Siapa nama?
Muhammad Amirul Amri Adam.
Muhammad Amirul Amri Adam. Okay ni
Saya pun
saya
sama,
tik
Doctor. Muhammad Alif Aiman.
So who else?
Muhammad Abdul Karim.
Muhammad Abdul Karim. Okay, this one. Okay. Okay, I already
Okay,
tick
thank
this
you,
one.
Doctor.
Okay, welcome.
Muhammad Khairul Hafiz.
Siapa? Muhammad Khairul Hafiz.
Ya.
Muhammad Khairul Hafiz. Ni Muhammad Khairul Hafiz. Okay, selesai.
Thank you, Doctor.
Okay, welcome. Who else?
Me, Doctor, Yang Chisam.
Okay. Yong Chisam. Okay.
Yes. Okay, thank you, Doctor.
Okay, welcome. Who else? Siapa lagi? Anyone?
Nama saya dah tick Doctor.
Nama
Saya
siapa?
Saya dah scan tapi tak tahu jadi lag. Nama Muhammad Alif Aiman.
Muhammad. Siapa? Aiman apa?
Muhammad Alif Aiman.
Alif Aiman. Alif Aiman dah.
Dah. Tak apa kalau dah. Thank you, Doctor.
Okay, welcome. Who else? Okay. So 3 students absent. Okay. So anyone? 3, 2, 1. Okay. So I will stop the. Okay, I will stop.